Okay, we're in section 36, and again, the related stage code. So I'm just gonna, start typing. Reset, exit variable. And then I see this function f of x, and I'll just copy it down. It doesn't look that familiar to me, though. Looks really tough, Joe. All right, I copy paste. That went pretty good. Let me do this numerical integral. Wow. All right. I'm getting something really weird there, huh? So let me just copy paste this one too. So we have something new there, numerical integral and integrate. So I'm just going to scroll back over the notes, and I want to see if I can see a problem. Again, don't be discouraged when you're looking back over things. If you're studying, though, looking back over things is a necessity, right? Particularly when you move forward, to look back over to see if you see any relationship between what you're doing now and what's in the past. There should be some relationship. It would be ridiculous otherwise. And again, some people's memories are better than others. Yeah, and that's a problem. Our memories sometimes, especially if we're not engaged enough, we really can't remember what we've done. And sometimes the reason we can't remember what we've done because we didn't do it. All right, we didn't do it, and that's a problem. Or if we did do it, it's such a long time ago, can't remember ever doing it. Right, it happens to me too. I'll sometimes look back over problems that I've done, many, many years ago, and I say I can't remember ever doing that problem, but I know that's my writing, my name's on it. Right. Just scroll back. Boy, these notes are long, aren't they? Mathematic code, Sage code's in there. A lot of stuff going on here, isn't there? Wow, I see this one. Pi over 12. Right? So I want to point out that this was a problem over here. And I just want to go through that with you. That I did this one over here. It says optional. I want to read it to you though. Optional. I was asked to review another instructor's exam to see if it was too difficult. This happened years ago, by the way. Chairperson came to me, said to me, could you look at this guy's exam and tell me if you think it was fair? Right? Now, fair means compared to what though? Probably compared to mine. All right. It would be nice if everyone had the same exams, if all teachers had the same material to teach from. We try to do that, but it's really tough to get people to follow. All right. So anyway, I was going to say that, I got to be honest with you. After I looked at the guy's exam, I thought this was, his exam was tough though. Really, I think he was probably upset with his students, and he was just giving them, showing them that they really weren't at the skill level that he was expecting by giving them an exam like this. I wouldn't do it though. I'll be honest with you, I wouldn't do it. But what I do over here is I rewrote the guy's problem down. And then I worked his exam. I didn't have the answer. I worked his exam. And I thought it was a bit tricky. I'll be honest with you. I thought it was a bit tricky. I thought to myself, at this level of the game, this would be tricky. We're not trying to trick students, though. At least I'm not. I'm not trying to trick anybody. All right. But anyway, I go through all the paperwork over here. Like I go through all the work. And someone says, oh, it's a lot of work. And yeah, maybe it is a lot of work for you. But the bottom line is it's not bad. Pi over 12, I get an answer. All right. And by the way, there's a ton of problems that you could give me that you might be able to do because you see something that I don't see. It happens all the time. All right. So I want to do another one with you. And the one I want to do, scroll back over it, is this optional problem number 9. And what does optional mean? You don't have to do it. But it says a student, and this guy, next student, you're not a student of mine, by the way, he just stopped by for office hour help. And I'd give him help. He showed me this problem over here. When he initially showed me the problem now, he had no limits of integration on it. And I said to him after he gave me the problem, I said, no, it can't be done with elementary techniques. And he said, no, someone's already done it. I know they've done it. I know they got an answer to it. And that's when he said to me, oh, you know what? I forgot to give you the limits of integration. So once he gave me the limits of integration, the first thing I would do, right, I'll be honest with you, if a problem is tricky, probably the first thing I would do, and I hate to say this to you, I would say, I wonder, really, can it be done? And what I would do, let me point out what I would do. I would use Sage, and I would just simply type it in. So I want to put out, reset, X is a variable. I define the function. What's the function? It's the integrand. And then I would try to integrate. I would actually try to integrate. I would try to integrate f of x with respect to x from 2 to 4. And watch what happens. So Sage is looking at the problem now. And it's saying, I wonder what technique I could do to solve the problem. And what's going to happen to Sage, by the way, Sage is going to come back with basically the same thing I gave it. Right? Basically the same thing that I've given it. All right. Now someone says, well, what would you do then? Well, I don't know. I guess some of the things I could do is I could look at what Sage said and say, no, it's not possible. But then I have to go back to what this guy gave me the problem. He said, yeah, it's possible. It's possible. So then I'm gonna ask Sage again. I'm gonna ask it in a different tone. And the tone I'm gonna give it is, I'm gonna say, could you do an approximate answer to this? All right. So what I would do is, I'm not going to say integrated. I'm going to say numerically integrated. So then Sage is going to say, oh, you really don't want to know what the exact answer is. You want me to approximate it. And I'll do this over here. So it spits back this number over here. All right. Now I wouldn't worry about the second number over here. That's a really small number. Right. But I notice it's saying that it integrates to 1.0. I got to be honest with you. That to me is remarkable, that this thing actually integrated to 1.0, right? With a level of approximation of a high degree level of approximation. So I'm going to claim over here is that once I see that, I'm saying to myself, if this turned out to be 1, it's probably going to be easy to do. Probably going to be easy to do. So I'm actually using a computer algebra system to see if it could do it numerically. By the way, I couldn't do it exactly, but it did it numerically, and it said it was 1. So I have strong suspicions that this problem is probably doable, just like that student told me that the problem is doable. Would it take me time to get through it? Yes. So what I do is I went through what I did for the problem, and I wrote it down. I wrote down all the steps for you. All right. Now someone says, I don't like your steps. Well, it's a good example of use substitution, and that's what I did. So I reworked the problem, did my use substitutions, and I finally, look at all that work. I finally get down to the answer, and I did it exactly. It is in fact 1 with no error whatsoever. All right. So here's the deal. Let me read this to you. You might want to think about this and see if you can think of another way of doing this problem. I'm not saying my way is the best way of doing the problem. Maybe it's not. Maybe you're going to say, no, I think there's a better way of doing it. By the way, Sage is not the better way of doing it. Sage couldn't have done the problem. Sage could do it numerically, but it couldn't do it. It couldn't get the antiderivative to it. So, and by the way, I can't get the antiderivative either to it. What I'm saying is I could find a manipulation to get through the problem and eventually get to the bottom of it, seeing it's 1. So seeing problems and their solutions may help improve your ability to solve unfamiliar problems. And that's where a lot of students don't realize, when we give you exams, as opposed to what that other instructor was doing, when I give you exams, and most of your exams at Essex County College are going to be problems that you've seen before, which makes the exams really easy. All right. In a competitive space, though, typically you're given problems you have not seen before, that to rely upon your ability to synthesize what you know from the past to find a novel solution to a newer problem. All right. But again, let me repeat this. Most of the problems that you see on our exams at Essex County College will be problems that you've seen before. Now, when I say that, if you're doing what we're telling you to do, which is study, a lot of students show up to exams having done little to no work, right? And of course, they're shocked when they can't answer anything. Anyway, the more problems you work, the better you become at solving problems. It's like they're puzzles, all right? They really are puzzles, all right? So I'm going to say you have to start to realize that integrations can be incredibly difficult. It isn't like differentiation. Integration's far more difficult. And why is that? You're going backwards on a problem that may not go backwards. All right. That may not go backwards. All right. Thank you for your attention, and we'll move forward. Thank you so much.